We're continuing our discussion on how to secure your application inside AWS. We previously talked about how to set up your VPC with public subnets and private subnets, and using routing tables to control access to the gateways. We now want to move on to access to individual instances inside your application. How do we control permissions so a front-facing web application can only talk to an application instance, the app can only talk to the database, and this is done through the AWS engine called security groups. Every instance inside your VPC already has a security group around it. This is core to EC2 technology. And you can think of a security group as a firewall around each individual instance that by default blocks all incoming traffic. It makes for a very boring instance. So what developers do is they take the firewall and they write explicit rules inside the security group itself that authorize a particular source of traffic. And the source is defined as IP address, protocol, and port. And IP range is actually what we mean. So if I want my application servers to only accept traffic from the front-end web servers, then I only open up a hole on the security group that will then accept traffic from the range, the port, the protocol from the web servers themselves. Database is going to have its own security group around it. And it is only going to accept traffic if it originates from the application server. Your front-end web servers, they also have a security group, and they are the only ones that are going to authorize traffic from 000 coming in from the outside web land to communicate to the web server. So this is what we call stacked security groups. Any traffic coming from the outside cannot communicate to the application server or the database, first of all because of the route tables, but secondly because the security groups do not accept traffic from 000. They only accept traffic originating from the web server. The only thing anyone from the outside can connect to is that front-end web server, the only one security groups allows, and then from there I can only connect to the app, from the app only the database. And what this does is this builds layer and layers of protection in the event of unknown flaws. For example, what if there was a vulnerability on your front-end web server that for whatever reason one of your application developers left a flaw, left an unclosed element that a nefarious hacker sitting out there in webland was able to exploit. And from here, because the security group is open from 000 only over port 443 or port 80 if you're old school, she was able to connect to this instance, exploit this imaginary flaw, and gain root access to that instance. In this unlikely scenario, does nefarious hacker, does she now have access to try to communicate with the database and break into it? The answer is no. Even though the route table would allow the path of a packet to exist, the security group around the database will deny any attempt from the web server to communicate directly with the database. This is simply not permitted. Instead, the only thing that she'd be allowed to do is to communicate to the application server, but only over the application port, which you pretty much could have done anyway by simply communicating with the web app itself. In the meantime, because she is now at root in this web server, it is very likely that you have installed some level of operating system protection, whether it's AWS Inspector or some other process sitting on the operating system that realizes that someone is sitting at root, expected number equals 0, actual number is more than 0, at which point the instance itself reports that it's in a violation state, that it is compromised. What can it do? It can dump its logs off to S3, it can send a notification off to your system administrators, and then as a final act, terminate itself. And it no longer exists, all within seconds of nefarious hacker exploiting this imaginary vulnerability. This is security in layers. This is security that expects any individual element might be compromised, and so we have layers upon layers upon layers, each one of them completely able to block an attack. Which ones do we use? We use all of them. Security groups exist around every instance, which means the first thing your developer is going to do is open up that security group to all ports, all protocols, all IP addresses. I've seen this happen. That defeats the whole purpose of the security group. It'd be the same thing as if you bought a house and the first thing you did was take the door off its hinges and put a great big sign out front saying, "Come on in, lots of cookies." Nobody's fault if your cookies get stolen at that point. So as part of good security checks, your security manager should regularly be checking security groups to ensure that only public-facing instances ever have 000 ports open on their security group, and that your internal private security groups are properly tiered to only accept traffic from expected instances. Security groups become another key tool that we use to help protect our most valuable assets inside your application.